In this learning path, we are going to be using prompt engineering in order to teach ourselves Python. We'll be using prompt engineering to generate code, to debug code, and also to explain code and other errors that we might encounter. Prompt engineering, of course, requires the use of generative AI tools such as ChatGPT. You can see here that I've logged into my ChatGPT account at chat.openai.com. ChatGPT is just a natural language conversation chatbot, and it's powered using an underlying model which is part of the GPT series. GPT, that stands for Generative Pre-training Transformer, is just a large language model that powers ChatGPT. Now, there are different versions in the GPT series. We'll be using GPT 3.5, which is available absolutely free. As we use ChatGPT, I'm going to keep this left panel closed so that we have enough room for our conversation. Now, in addition to ChatGPT, I'm also going to be using Google Bard. Google Bard is Google's natural language conversation AI service. I'm logged into Bard with my Gmail account. Bard is once again available for absolutely free. You'll find that Google's Bard chatbot has many of the same capabilities as ChatGPT, but the underlying large language model that powers Google Bard is different from the GPT series that powers ChatGPT. Google Bard uses a model known as PaLM 2, where PaLM stands for Pathways Language Model. It's a large language model with a different architecture trained on a slightly different dataset, which is why you'll find that Bard's responses will often be different from ChatGPT's responses in many cases. Bard is available at bard.google.com, and you'll need to sign in with your Gmail account to access Bard. Now, the third conversational AI service that I'm going to use is Bing Chat. Now, Microsoft's Bing has an integration with ChatGPT's OpenAI, and Bing is in fact powered using the GPT-4 model. The GPT-4 model is a major improvement over GPT 3.5, and it's less prone to hallucination. It's more likely to give you correct results and less likely to lead you wrong. Bing Chat is available at bing.com, and you'll need to click on the Chat tab, and that will bring up this user interface that you see here on screen. Bing Chat allows you to configure the kind of conversation you want to have with its conversational bot. You can have the conversation be more creative or more precise. The default option here is more balanced, and we'll stick with that option for all of the queries that we'll ask Bing Chat. Now, here you're going to be learning Python, but let's confirm using ChatGPT and other Gen AI tools that Python is the right language for you. If you've used other programming languages and you want to learn Python, well, it should be very easy for you to get started. But Python is ideal for beginners. Let's confirm this using ChatGPT. I've never coded before and I'm eager to learn what programming language should I start with. Now, here, ChatGPT does not give me one definitive answer, but you can see that Python is there at the top of the list. As a general purpose language, it's the best programming language for beginners. It has a simple, readable syntax, very true, makes it easier to learn and understand. And Python is also used in a number of different domains. So it's definitely a great programming language for beginners, and that's likely why you're here in the first place. I'm kind of curious about what Bard has to say to this, so I'm going to ask Bard the same question. I've never coded before, I'm eager to learn what programming language should I start with, and Bard is quite clear in its choice. Python is the right programming language for beginners. The structure of the response is different, but the points are essentially the same. It's a general purpose programming language used for a wide variety of tasks with a simple and readable syntax. Bard, in addition, gives you some tips and tricks for learning Python as well. Let's see if the verdict is unanimous. I'm going to switch over to Microsoft Bing and ask it the exact same question, and Bing gives me many more responses. It talks about HTML, which is not really a programming language, talks about CSS, JavaScript, but you can see that Python is in there as well. Now that it's pretty clear that Python is a great programming language for beginners, let's now discuss what we need to get started programming in Python. Now, if you're going to be writing code, you need a code editor. The code editor should make it easy for you to write code in that language, give you autocomplete, and a bunch of other features to run your code. As a beginner, what code editor should I use to write Python? Well, it's pretty clear that there are many options here. Idle, PyCharm. Notice this Jupyter Notebook option. This is the one we are going to be using. Jupyter Notebooks is great for beginners because it's very easy to set up and use. It gives you a web-based interactive development environment. The interactivity makes it very easy for you to write a few lines of Python code and see the result of running and executing that code. You get quick feedback, allowing you to learn from your mistakes as you're coding. Now, I asked the same question of Google's Bard and Microsoft's Bing Chat, but they did not give me Jupyter Notebook as a viable option. But it's by far the best one to use. I was kind of disappointed. They suggested only environments which are better for large scale projects. Now, the next question is, how do you get Python on your local machine? And this is what I asked Chat GPT. Now, here in this response, you can see that there are different ways to download and install Python on Windows, on Mac OS, and on Linux machines. So, based on the kind of machine that you're using, there are a different set of steps that you need to follow. Now, rather than have each of you follow different steps based on the kind of machine that you have, let's install a distribution of Python that works in a cross platform manner. And this distribution will also install Jupyter notebooks for us. And the distribution of Python that I refer to is Anaconda Python. Now, Anaconda is a company that makes available the Python and R programming languages as a part of its own distribution. The Anaconda distribution of Python is freely available for personal use, though you have to pay for enterprise use if you're using it as a part of an organization. There are many good things about the Anaconda distribution of Python, but the most important thing is Anaconda is cross platform. You download and install Anaconda no matter what operating system you are on in almost exactly the same way using the Anaconda installer. And not only will you have Python installed on your machine, you'll also have Jupyter notebooks. This is the interactive web environment that we'll be using to develop in Python. Now that we know that we're going to be using the Anaconda distribution for Python, let's switch over to Bard and ask Bard how to get set up with Anaconda on your local machine. Any question which requires absolutely up to date information available on a website somewhere, I like to ask Bard or Bing Chat because they have the ability to scrape the web and then respond to your queries. At the time of this recording, ChatGPT's free version has only been trained on data up to September 2021, so it won't have up to date information for many small details. Now you can see that to install Anaconda Python, you need to go to the Anaconda website and download the right installer. It's pretty clear that the installation steps are fairly straightforward, which means we can go ahead and get started. Let's install and set up Python on our Mac OS machine. Here I am in the terminal window. Now on the terminal prompt, I'm just going to run Python to see whether Python is already installed. It's quite possible that Python is already installed on your machine, and if you do not get command not found and you enter into some kind of interactive shell, well, simply type exit open close brackets and get out of that shell. You already have Python installed. As long as it's some version of Python 3, you should be good to go for all of the demos of this course. Now, if you don't have Python installed, let's install Anaconda Python on our Mac OS machine. You can simply search for install Anaconda on Mac, and let's click through to this link where we'll get instructions on installing on Mac OS. Now, the instructions that you see here on this web page are the instructions that we are going to be following. So you can follow along the documentation, or even simpler, just follow along in the video. Now, somewhere near the top of the page, you'll find a link for the Mac OS installer to install Python, and that'll take you to another page. Here, you can click on the download button that you see here to install the Mac OS installer. Observe that this page has correctly identified my current operating system as a Mac device, and you can see the little Apple icon next to the download button. The download links for the installer are also available here at the very bottom of this page. You can see the download links for Windows, Mac OS, as well as Linux. The latest version of Python at the time of this recording is Python 3.11. However, any version of Python, Python 3.7 or newer, should work for all of the demos of this course. Click on the graphical installer and this will download a pkg file onto your local machine, and this package file is what we'll use to get set up with Python. Once the download is complete, you can open up your downloads folder and you should find the pkg file there, and I'm going to double click on this file in order to start the install process. This will bring up a wizard that will walk me through the install process. Click on allow to allow the package to run, and click on continue through all of the pages of this wizard. There is a readme here. You can read this if you want to, but my suggestion is simply accept all of the terms, click on continue. Here is the license for using Anaconda Python. You might want to read through this, but I'm going to accept all of the terms and click on continue once again. Make sure you agree to the terms of the license, otherwise you won't be able to install Anaconda Python. I'm going to install only for my current user. I don't want Python installed for all of the users of my machine. Click on continue once again. The installation will take up about 4.5 GB of space. That's totally fine. Let the install process run through. This will take about a minute or two. Once the software has been successfully installed, you should see this last page which talks about the ability to code on the cloud using Anaconda Python. Well, we'd rather code on our local machine. Click on continue. Go ahead and close out this installation wizard. At this point, not only do you have Python installed on your machine, you also have Jupyter notebooks. You can choose to keep the package file or move it to the bin. Now back in my terminal window, I'm going to run the Python version command, python dash dash version, and you'll see that this now returns the Python version that has been currently installed, 3.11.4. When you install Anaconda Python, not only do you get Python on your macOS machine, the installer also configures the environment variables that you need to work with Python and with Jupyter notebooks. I'll set up a working directory where I'll create all my Python notebooks where I'll write code. Make sure that you're in the home folder, so cd tilde will ensure that. Within the home folder, I'm going to use the md command to create a new subfolder called Learning Python. Once you've done this, let's cd into this Learning Python subfolder, and that is going to be my current working directory for all of the projects. We'll run our Jupyter Notebook server here in this learning underscore Python subfolder. Now, before we do that, let's confirm that Jupyter Notebooks is indeed installed and available. Run Jupyter dash dash version, and you can see the version of Jupyter that we are using. Any version of Jupyter Notebooks above version 6 should work. Now that you confirm that Jupyter is indeed installed, let's run Jupyter Notebook, and this will bring up the notebook server. The notebook server is just like a web server running on your local machine, and you can actually access this web server using this URL link here. In fact, Jupyter Notebook should automatically open up in a browser window, but if it doesn't, you can simply copy and paste this URL link into your browser. By default, the notebook server will run on localhost port number 8888. And this is what the notebook server looks like. I have no notebooks present, and that's why the home page of the server is absolutely empty. You can create a new notebook to write Python code by clicking on the new drop-down and choosing the Python 3 kernel. The kernel is just the engine that will execute our Python code. So choose Python 3, and this will open up a new notebook within which we can write code. All your code will be written within notebook cells, and you can see a single cell here in this notebook. We'll create more cells as we need them. On the top right, notice that we're running the Python 3 kernel. You'll get more familiar with the notebook as we use it, but for now, let's rename this notebook to have a meaningful name. I'll just show you how to do it. Just click on Untitled, and you can call this notebook anything. Let's call it My First Python Notebook. You'll find that all your notebooks are saved as IPYNB files on your local machine, and that's just the Jupyter Notebook format. Any IPYNB file, Jupyter Notebook should be able to open up for you, and you should be able to run code in that notebook using the Python kernel. If you're a Windows user, this is the right video for you to watch to get installed and set up with Anaconda Python on Windows. You can see I have the command prompt open, and I run Python on my command prompt, and it gives me nothing. Python is clearly not installed. I'll now open up a browser window and perform a search for install Anaconda on Windows, And the first link that you get within your search result should take you to the Anaconda installer page. Here you can see all of the steps that we are about to follow to install Anaconda Python on a Windows machine. Now you can choose to follow this documentation, or you can just follow along with me in this video. Click on this link available near the top of the page that will download the Anaconda installer. This link should take you to another web page where you'll find a big green download button that you can use to download the installer. Observe the button is next to a Windows icon. This page has detected that I'm currently on a Windows machine. You can download the installer by clicking on this button here, or you can scroll down to the very bottom of this page, and there you'll find links to download and install Anaconda Python on Windows, macOS, and Linux. I'm installing the latest version of Python here at the time of this recording, Python 3.11. But any new version of Python, Python 3.7 and up, should work for all of the demos of this course. Go ahead and save the exe file for the installer. And once the file is available in your downloads folder, you can click on that executable, and that will bring up an installation wizard allowing you to get set up with Anaconda. Let's click on next here. Here is the license agreement for Anaconda Python. Go ahead and click on I agree. Only then will you be allowed to install Anaconda Python. The easiest way to get set up with Anaconda is to install only for the current user. This does not require admin privileges on your machine. Also, you'll be able to get access to Python on the command line by configuring the path environment variable. I'll show you that in a bit. Make sure that the option that you pick here is install for just me. Click on the next button. Here you'll be able to choose where you want Anaconda Python to be installed. This is the default folder that works just fine. Click on the next button, and that will take you to a page where you can specify some configuration options. In order to ensure that you can work with Anaconda Python from the command prompt on your Windows machine, you can simply add Anaconda 3 to your path environment variable. Now, this is not the recommended way, but it's by far the easiest way to get set up with Python. As a beginner working on Python, this is the option that I would recommend to get set up easily. Click on install and wait a few minutes for all of the packages to be installed, and soon you'll be up and running. Click on next, and that will bring you to the last page of this wizard. Uncheck launch Anaconda Navigator. We launch Jupyter Notebooks from a command prompt instead. Click on finish. Once you've completed the installation, go back to your command prompt, and let's get set up with the current working directory where we'll be writing our Python code. I run the makedir learning Python command to create a directory called learning Python. Let's cd into this directory. That's going to be our current working directory. This is where all of our notebooks where we'll write Python code will be stored. Our Python installation is complete, so let's check that Python is indeed installed. Python dash dash version shows me that I'm working with Python 3.11.4. But like I said, any recent version of Python, Python 3.7 and up, should work for the demos of this course. Now, once I have Python installed, the next thing is for me to check whether Jupyter notebooks are installed. Run the activate base command, and once you've done that, let's see if Jupyter is installed. Run Jupyter dash dash version. This will give you the versions of Jupyter notebooks that you have installed. You can see a number of different components here and the versions for each. As long as you have Jupyter notebooks version 6 and up, you should be just fine. In order to work with Jupyter notebooks, you need to run the notebook server, and this you do by running the Jupyter notebook command. The notebook server is just a web server that runs on your local machine, and you can access this web server using this URL that you see here on screen. Usually, when you run the Jupyter Notebook command, a web page should automatically open up and point to the notebook server. If it doesn't, you can simply copy and paste this URL within a browser window, and this will lead you to the notebook server. You can see that we have no notebooks created at this point in time. A notebook is what you'll use to write Python code. In order to create a notebook, you can click on this new drop down and choose the Python 3 kernel. The kernel here just refers to the engine that will interpret and run our Python code. Select this option and you can see that a new notebook has been created and is now available for you to use. Observe at the top right of the screen that we're using the Python 3 kernel. Now, all of the code that you'll write within Jupyter Notebooks will be within the notebook cells. And there's exactly one cell created here in this notebook. We'll create new cells as we need them. But before that, observe that this particular notebook has no name. You can click on this untitled name of the notebook in order to rename the notebook and give it a meaningful name. I've called this my first Python notebook. At this point, you're up and running with Python and Jupyter Notebooks and ready to start coding. Here I am ready to start learning Python with the help of generative AI tools. I've created a brand new notebook for my very first program and I've named the notebook Variables, Comments, Data Types. I have the notebook open on the first tab of my browser window, and on the second tab I have Chat GPT, the third tab is Bard, and the fourth tab is Bing Chat. On the top right, you can see that this notebook is running the Python 3 kernel. Observe that there are a lot of code cells here in this notebook. Now, when you create a new notebook, it starts off with one code cell. How did I get so many? Well, I placed my cursor inside that code cell and I hit Shift Enter multiple times. When you hit Shift plus Enter or Command plus Enter or Control plus Enter on an empty code cell, it will simply create a new code cell. And I did that multiple times to get all of these code cells here. You'll use the same keystroke combination to execute code that you write within a cell as well. Let's get some more room for our code here in this window. I'm going to click on View and toggle the header for this particular notebook. If you toggle header, the header will disappear. You can no longer see the name of the notebook. And if you toggle line numbers, you'll be able to turn on and off line numbers for individual code cells. I'm going to turn on line numbers so that if I write multiple lines within a code cell, we'll be able to use these line numbers to reference individual lines. In addition, I'm going to toggle the toolbar that is shown with every notebook. All of this will give us additional room to work with. As we are studying Python, you'll find that I'll reference ChatGPT, Bing Chat, and Google Bard several times in order to get me through the process of learning Python. However, you'll find that I'll do so more later in the course rather than earlier in the course. When you're getting your first concepts in Python straight, well, it's easier to follow along with a video rather than by asking ChatGPT. The first thing you have to learn in any programming language is the idea of variables. A variable is just a store of data. Here, num underscore 1 is a variable that stores the value 50. In order to execute this bit of code that I have here in this code cell, I can click on the cell option and choose the run cell option. Notice the 1 next to the code cell that indicates that that cell has been executed. The variable num underscore 1 now contains the value 50, and if you reference num1, you'll be able to access this value of 50. So I'm going to reference num1 and then call run cells once again, and notice it produces the output 50. And this is why Jupyter Notebooks are such a great tool to learn Python. You can simply type code into a cell and run that bit of code, and you'll get output right there just below your code cell. 50 is the value contained in the num1 variable. Now I'll initialize a second variable called num2 and I'll have it hold the value 124. Now rather than using the drop down and then run cell to execute the cell, I'm going to hit shift enter and shift enter will actually execute the cell. Num2 now contains the value 124 and you can just type num2 and hit shift enter and the value 124 will be printed to screen. A programming language at its very heart is a calculator and you can use it to perform all kinds of computations. For example, if you want to sum up num1 and num2, you can simply print num1 plus num2 to screen, hit shift enter and you'll get the sum of the two, which is 174. Num1 and num2 are both variables. Variables have to start with a letter and can be made up of uppercase letters, lowercase letters, and a few special characters such as underscores. Now, what about num underscore not exists? Is this a variable? Let's hit shift enter and see what the result is like. When you do this, you immediately encounter an error which says num not exists is not defined. What exactly does this error mean? Well, let's turn to ChatGPT and find out. The best way to do so is copy this error over. Let's switch over to Chat GPT and ask it a question. My question is as simple as, what does this error mean? I use the triple hashes to separate the error from my instruction, and then I've pasted the error in. Let's see what ChatGPT has to say. The cool thing here is I did not have to specify to ChatGPT what language I'm using. ChatGPT figures this out by looking at the error. And you'll find that this is true not only for the Python programming language, but also for other common languages such as C Sharp or Java. The name error is a built in exception. An exception is just something that Python uses to flag errors in your code. And you can see that this exception is thrown when you try to use a variable or a name that hasn't been defined in the current scope. Python doesn't recognize this particular name. ChatGPT also tells you how you can fix this error. You need to define the variable before using it by assigning it a value. For example, here num not exists equal to 42. Well, let's try this in our notebook. I'm going to initialize num not exists to 42. This is where I assign a value to the variable num underscore not exists. And then I'm going to use the print function, a built-in function in Python, to print out the value of num not exists. Shift enter, and you can see that num not exists has a value of 42. We now know how to define variables. We also know how to use the print function to display the value of variables. Let's try this once again. I'm going to define a variable called sum var that I set to 1001, and I'll use the print function to print out the value stored in sum var, and it's 1001. Python is a dynamically typed language. Here, the variable sum underscore var holds the value 1001, that is an integer value. However, you can assign a different type of value to sum var later on in the program. For example, if I want sum var to hold a string value, that is just a piece of text such as mango, well, that's totally legitimate. Samvar now contains the value mango, which is just a piece of text, and a piece of text is referred to as a string. And if you're curious about this behavior, you can actually ask ChatGPT. It seems like I can assign different types of values to my Python variables. How is that? And you can see that ChatGPT explains dynamic typing to you. A variable's type is determined at runtime based on the value that it holds. So if you have a variable holding an integer at one point in time, it can hold a string or a floating point value at a different point in time. So the type can change. There's a lot more to read here, but let's not get overwhelmed with all of the information that ChatGPT gives us. Instead, what I'm going to do is copy over some of the code by clicking on the copy code link, and then paste that code into a code cell here in my notebook and execute that code. Here is something you may not have seen before. Notice on line 1, after we have the code x equal to 5, we have a hash sign and then something that's known as a comment. X is an integer. Whenever you write code in any programming language, you use comments to explain what the code does. Comments help make clear to others who are looking at your code what exactly is going on. A comment in Python is preceded by the hash symbol. Everything after the hash symbol to the end of the line is a part of that comment. Here in this code cell, I have three comments: x is an integer, y is a string, and z is a float. Any code executed in Python will completely ignore anything that you have as a part of a comment. Here you can see the different types of data that you can store in variables. X holds an integer, Y holds a string, and Z holds a floating point value. I can simply type out X, Y, Z separated by commas, and the value of these variables will be displayed to screen. Now, if the same variable can hold different types of data at different points in your program, there should be some way to tell what kind of data is held in a particular variable. This makes logical sense, so I turned to Google Bard for some help. Is there a way to tell what type of data is held in a particular Python variable? Well, there are two ways. You can use the type function and you can use the isInstance function. I'll leave you to try out the isInstance function on your own. This is where you pass in a variable and a data type and check to see whether that variable is of that data type. The type function, I feel, is something that is useful for a beginner. Let's copy over this bit of code and paste that into a code cell. I have my variable initialized to an integer value and I print out the type of my variable and you can see it's of class int. When you use ChatGPT, you might encounter code that is not familiar to you and requires a little bit of parsing. Notice here, I pass my variable to the type function, and then whatever type returns as a result, I pass that result to the print function and print prints it out to screen. This might be a lot to parse for a beginner, but you'll find this construct used over and over again in Python programming, and you'll soon get used to it. Let's try this once again. I'm going to initialize a variable called myString to the string hello world and then print out its type. And you can see that it belongs to the class stir. Once again, I pass in myString to the type function, and whatever the type function returns, I pass that as an input to the print function, and that is what is printed to screen. If you only want to invoke the type function, you can do that as well. Here I initialize myString to hello world and print out its type, and its type is simply stir. We've seen the integer data type, we worked with the string data type. Here I initialize the variable pi to the value 3.14 and 3.14 has type float. This is a floating point value. We know that Python supports strings, integers, and floating point types. It's only natural at this point in time to turn to one of our AI assistants and ask what are the different types of data that I can store in Python variables. Let's see what Bard has to say. You can store numbers, integer floats and complex numbers, strings, sequences of characters, lists, tuples, sets, and dictionaries. We won't worry about the last four. There are more complex types. We'll look at that in a later demo. Meanwhile, let's look at some of the primitive types that Python supports. Numbers and strings are the most basic of types. I'm going to copy over this bit of code and let's paste that into our notebook cell and let's execute this code. We now have four variables with four different types of values. My integer contains an integer value. My complex number contains a complex number value, 1 plus 2j in our case. I'll leave it to you to explore some of the other variables that we have initialized here. Instead, I'll show you a kind of variable that Bard did not tell us about, the Boolean variable that can hold true or false values. Here, Boolean underscore true holds the value of true and Boolean false holds the value of false. Notice that true and false are special keywords in Python. There is another special type of variable that Python supports, and that is the none type. None in Python represents the absence of a value. It's the equivalent of null values if you worked with Java or C Sharp. Here I've defined a variable called none underscore value and I've assigned it the value none. None means the variable holds nothing. Now, if I print out Boolean true, it'll print out true. That's the value held in that variable. But if I were to print out none underscore value, it'll simply print out none. This variable holds nothing. None is the absence of a value. It indicates to others looking at this code that a value hasn't been assigned to this variable yet. Now, if you were to look at the type of this none value variable, it is of type none type. Again, another special type in Python representing none values. Now that we know the basic data types that Python supports, let's see some operations we can perform with values stored in variables. We'll start with simple arithmetic operations. Here I've initialized two numeric variables, numvar1 and numvar2. I add these two up on line 4 and place the result in the variable result and I print result out to screen. Observe how I use the equal to operator to store the result of numvar1 plus numvar2 in result. And result here is 112.6. You can use the plus operator in Python to add two strings as well. I have two strings here, string var1 and string var2. On line 4, I perform the string concatenation operation. String var1 plus a blank space, that is a string with just a space in it, denoted with double quotes, plus string var2. This is string concatenation and the result will contain howdy Richard with a space in between. However, if you try to add a numeric value with a string, things will not work like you expect. Num var1 plus string var2 gives me this error. You can see this unsupported operand types for plus. Maybe you thought you were adding two numbers together and you ended up with this error and you don't understand why this is actually happening. Let's copy this error over and let's head over to Chat GPT and ask it what this error is trying to say. I was trying to add two numbers together, but I got this error question mark and I've pasted the error in here. Now, Chat GPT gives you a very clear response. What we've got here is a type error telling you that you're performing an unsupported operation, adding a float and a string together. So you can't directly add a float or a string using the plus operator. You can only do so by explicitly converting one of them to a compatible type. And here below, ChatGPT gives you an example of how you can convert a numeric value to a string type. Let's copy this code over and execute it in our code cell. Observe here in this code, I use the str function to convert the numeric value to a string type. Now I'm adding two strings together. The numeric value held in num_var1 will be converted to a string and that will be added to the string in string_var2. And I get 34.6 Richard. Nothing meaningful, but we successfully performed the concatenation operation by converting types. Now, let's say you try to perform a similar operation, but the first operand you specify is of type string. Here, I add string var1 plus num var2. So the first operand is of type string. Notice that the error message here is different. You can only concatenate string and not integer to string. So you can concatenate two strings together, but you can't concatenate an integer and a string. And let's ask ChatGPT what this error means. Maybe you thought you were trying to concatenate two strings together. So you tell ChatGPT, I tried to concatenate two strings together, but I got this error. What does this error mean? And here is the error that I copied over from the result that I got. And ChatGPT again is very clear. You can concatenate two strings using the plus operator, but you cannot concatenate a string and an integer using plus without actually performing some kind of type conversion. There are many different ways in which you can convert the integer to a string type and get the result in the form of a string. Now, I'm going to look at just the first of these techniques. We look at the other techniques in due course. Let's copy the first bit of code over where I use the str function once again to convert the numeric value in num_var2 to be of type string. The str function performs this conversion and now what we're doing is concatenating two strings together and we get a result without an error. Howdy exclamation 78. Now that we have a handle on variables and data types, we can write a little more complex code with ChatGPT's help, of course. We'll give instructions to ChatGPT using a code generation prompt and then we'll understand what the generated code does. Notice that I've used the hash symbol, which is used to define comments in Python, to have ChatGPT generate code in Python. This prompt is an example of code generation using comments. Now, the first comment line says Python, indicating that I want code to be generated using the Python programming language. The second line in the comments is an instruction for what I want the code to do. I want the generated code to ask the user for their name and the city in which they live, and then I want the code to greet the user. The instructions are clear and step by step. And since this is a fairly simple program, ChatGPT should get this right away. ChatGPT also gives you an explanation for what this code does. And when you're actually working on this course, I suggest you read that explanation. But for me, I'm going to copy this code over and paste it into a code cell. And as we're executing this code, we'll discuss what it does. Observe how ChatGPT has used comments to explain what each line of the code does. On line 2, we invoke the input function, and the string that we've passed into the input function is the string that will be displayed on screen, prompting the user for their input. Essentially, the user will see what's your name, and the input text box will allow the user to enter his or her name. Whatever value the user inputs will be stored in the name variable. Now, the second line of code on line 5 is another input function where we prompt the user to enter their city. The user's input will then be stored in the city variable. And finally, the code on line 8 will greet the user. So if you're John from New York, the greeting will say, "Hello, John from New York, nice to meet you." You might find that string that you see there in the print function a little strange. You may not understand it, but we'll ask ChatGPT for help in just a bit. But first, let's execute the code and take a look. You can see the text prompt there. What's your name? This is where you'll type in your name. Let's say you type in Nora and hit enter. Let's type in the city and you get the greeting. "Hello, Nora from Paris. Nice to meet you." Now, if you hit shift enter on the code cell once again, the code cell will be re executed. The same lines of code are run through once again. What's your name? This time I say Joseph and I say that I live in London and I get the greeting, "Hello, Joseph from London. Nice to meet you." We've successfully got ChatGPT to generate code, but there is a bit of code that we don't understand. I'm going to copy this print statement over and I'll turn to my AI assistant for help once again. I tell ChatGPT, "I did not follow this bit of code. Could you please explain this? What exactly is going on?" And let's see what ChatGPT has to say. What we have here on screen is a special kind of string referred to as a format string or an F string. An F string is specified in quotes and is preceded by the character F. F strings give you a way to embed expressions inside string literals. So notice the curly brackets around the variable name and the variable city. Those curly braces enclose an expression. Name and city are both expressions. Here they are just variables, and the value of those variables will be embedded into the output string. And this is why you see "Hello, Joseph from London" or "Hello, Nora from Paris" in the result. It's the values of the name and city variables that are embedded within the actual resulting F string. F strings are confusing at first, but very useful, so you should definitely get some practice working with them. Notice I have four different variables here: name, age, distance, and statement. All of these variables are of different types, and all of these different kinds of variables can be embedded within F strings. I have three print statements using F strings where I reference the name variable, the age variable, the distance variable, and the statement variable. Let's hit shift enter and you'll see the resulting strings printed out to screen. Python evaluates the value of the expressions, in this case, the expressions are just the variables, and embeds the values within each string. I'm now going to change the values of these variables so that name is Joanna, age is 25, distance 6.7, and statement true. And I hit shift enter once again, and you can see the resulting strings have the new values of these expressions. Let's get some more practice with code generation in Python, and this time we'll use Google Bard. And you'll see that code generation with comments works in Bard as well. I want code to be generated in Python. That's the first line here in my prompt. Then the code should request the user to input two numbers and then display the sum of and the difference of and the product of these two numbers. For a simple use case like this one, Bard gets things right. What I'm going to do here is copy this bit of code over and we'll understand the code once we paste it and execute it in our notebook. Let's take a look at the code that Bard generated and understand what it does. Now here, once again, we use the input function to prompt the user to input something. We ask the user to enter the first number and then the second number. This is the code on lines 2 and 3. The value from the user that is collected by the input function is in the string format. We need to convert this to a numeric type before we can actually perform the arithmetic operations. And for that, we use the float function. So on lines 2 and 3, the input specified by the user is passed to the float function, which converts that input to a numeric type and assigns those numeric values to num1 and num2. On lines 6, 7, and 8, we assign the addition, difference, and the product of the two numbers to the variables sum, difference, and product. You can see here on line 6 that sum is in a slightly different font and color. That's because sum is a built-in function in Python, and if you use sum as a variable, then you're essentially overwriting the sum function and you won't actually be able to use that function in your code after you've executed this code cell. So you can see that Bard got the code right, but it gets these subtle things wrong. We won't worry about this right now. I'll show you the result of using sum as a variable later on in this course. And then finally, on lines 11, 12, and 13, I have the print functions to display the sum, difference, and product of the two numbers. Let's run this code and take a look at the result here. I'll enter the first number 23 and 56, and I get the sum, difference, and product of these two numbers. Let's try this once again with floating point values 1.3 and 4.6, and the code cell ran through successfully. But what if you were to enter something that is not a number? Let's say I enter the character T. T is clearly not a numeric type. Now, when the code on line 3 of your code cell sees this input character T and tries to convert that to a floating point value, it'll fail and throw an exception. You can see the value error here on line 3. The character T could not be converted to a floating point. We've seen how you can do code generation using comments. Let's look at describing a scenario and ask ChatGPT to generate code for us to tackle that scenario. Now, let's say you have the salary of an employee stored in a variable and you specify the name of that variable, salary, and you want to know how you increment the salary by 10%. Note that I don't indicate anywhere that I want code in Python, but yet ChatGPT correctly generates code for this using the Python programming language. And the reason for that is the context of the conversation. All of the previous questions I've been asking here in this session have been about the Python programming language, which is why ChatGPT continues to talk to me in Python. Here is the code generated along with an explanation for what this does. I'm going to copy this code over, paste it into a code cell in our notebook, and then we'll understand what this code does. You can see the ChatGPT first defined the salary variable and initialized it with a value of $50,000. Next, it incremented the value in salary by 10%. On line 5, you can see that it multiplies the current value of salary by 1.1 and stores this new incremented value back in the salary variable. After the code on line 5 is executed, salary will contain the new value with a 10% increment, and that new value will be printed out to screen. Let's execute this code and take a look, and you can see that the new value is 55,000.000, many zeros and then a 1. It's a rather imprecise value. It should just be 55,000 in my opinion. We'll try to understand that in just a bit. We'll of course use our Gen AI assistant for help. In the meanwhile, let's see some other ways that we can manipulate the salary variable. Observe that I've initialized salary to 50,000 once again, that is the code on line 1, and then I increment the salary by $1,000 using plus equal to. Now, salary plus equal to 1,000 is the same as salary equal to salary plus 1,000. The plus equal to is called the in place addition operator. Because we perform these kind of operations very often in Python, plus equal to is a neat little shortcut that you can use. So you can say salary plus equal to 1,000 instead of salary equal to salary plus 1,000. And then we'll print out the new salary, which should have been incremented by $1,000. And you can see that indeed it has. The new salary is $51,000. Just like the plus equal to, you have the minus equal to. Once again, I initialize salary to $50,000 and then I compute salary minus equal to 1,000, which will decrement $1,000 from the original salary of 50,000, and the new value of salary will be 49,000. And this is indeed the case. Minus equal to is the in place subtraction operator. Let's try the same thing with other arithmetic operators such as multiplication. Here is the in place multiplication operator. Here I increment the salary by 10% by multiplying salary by 1.1, and the new salary once again is 55,000.000, many zeros and a 1. Now, why does this happen? We'll look at that in just a bit, but let me show you how you can divide using the divide equal to operator. Here I've divided the original salary by 10 to give me a new salary value of $5,000. Now I'm going to ask ChatGPT why this is the case. I'm going to copy this bit of code over and put in an explanation prompt here in ChatGPT. Here is my prompt. I have this code with increments in employee salary by 10%, but instead of 55,000, it gives me 55,000.00001. Why is that? And ChatGPT's answer is very clear. This has to do with the precision of floating point representation in Python. In most programming languages, not just Python, floating point numbers are approximations to real numbers and often exhibit small rounding errors due to how they are stored in memory. So 55,000 is actually stored with a small rounding error. So you get this extra very small fractional part along with the actual answer. And ChatGPT actually shows you how you can mitigate this in the formatting of your display. Let's copy this code over and execute it, and I'll explain what it does. Observe line 3, that's what is different. Here I format the salary using a format specification. The format specification is the same F string that we've seen before. Colon point to F basically formats the floating point number showing just two decimal places. Colon point to F is within curly brackets indicating it's an expression, and the dot format actually evaluates the expression for that string. The dot format is actually the function that is invoked on that string which contains the format specification. And the expression is evaluated on the salary floating point number. So now we'll print out the new formatted salary, and you can see that it just displays two decimal places. We worked a fair bit with strings in Python, and if you notice, we've always specified strings using double quotes. Now, you might have been curious about this, and here is a question you can ask ChatGPT. Are strings always defined using double quotes in Python? And our assistant makes it very clear that this is not always the case. You can specify strings using single quotes as well as double quotes in Python. Here you can see an example of each. There is no difference between single quoted strings and double quoted strings in Python. It really depends on your preference. I'll copy this bit of code over and we'll run this, and we'll see that both strings work the same way. So I'll print out both the single quoted and double quoted string, and you can see that both strings are printed to screen in exactly the same way. If single quoted strings and double quoted strings are the same, when would you choose to use one over the other? And ChatGPT's response gives you an example. If you need to handle a quote character within a string, that's when you'll choose a single quoted string or a double quoted string. Notice in this first example here in this quote, we have a double quoted string with a single quoted hello within that double quoted string. In the second example, we have a single quoted string with a double quoted hi embedded within the single quoted string. So if you want to embed quotes within strings, you should use quotes of the opposite type. Let's take a look at this example and understand how we made our choice. In the string on line 1, we embed hello in single quotes, which is why the entire string is wrapped in double quotes. In the string on line 2, we embed hi in double quotes, which is why the entire string is wrapped in single quotes, and both of these work perfectly well. You can see the single quoted hello and the double quoted hi displayed on screen. This got me thinking a little further. Let's say you have a double quoted string and you want to embed another double quoted string inside it. How will you accomplish this? Well, that's what I want to ask ChatGPT. The objective is to embed a double quoted string inside another double quoted string. I want to see whether this is possible. And ChatGPT tells me that this is indeed possible. And it gives me an example of how I can do this. Let's copy the example over and paste it into our code cell. If you want to embed a double quoted string inside a string specified in double quotes, you have to use the backslash escape character. Now, backslash quote here essentially tells Python that the quote character should be escaped and is a part of the string itself. The double quotes around example won't be treated as the opening or closing quotes of a string, but will be treated as a part of the string. And you can see this here in the result. Let's now see how you can have a string span multiple lines in Python. If you have a very long string and you want to write it across two lines, you might be able to see here that this really won't work. I get a syntax error. As with all errors, I'm going to ask my Gen AI assistant what this means, and this time I'm going to pose the question to Bing Chat. What does this error mean? And I paste in my error. And Bing chat is pretty clear. The error is caused because your first line of the string has not been closed with a quotation mark. If you want your string to span multiple lines, you need to use the backslash to split your string. And Bing gives you an example that I'm going to now copy over. Observe that at the end of the first line, Bing generated code with a backslash. A backslash tells Python that whatever line I'm writing right now is continued in the next line. And this now treats the entire two lines as a single string. You can see that this single string, very long string, has this extra space in between. And the way you can get rid of this space is to get rid of the space just after the backslash and before the start of the second line. Now we have a very long string specified across multiple lines. The backslash is a general technique you use in Python when you want code to span more than one line. Now, if you don't want to use the backslash with a string, you can specify your string in triple quotes as well. Triple quotes allow you to specify multi-line strings. And here is my same string specified in triple quotes. You can see that it's treated as a single string. However, there is a new line after the period, and then the second line of the string starts. And this new line exists because the two parts of the string are literally specified on different lines. And that is what the triple quote interprets the string as, a string with a new line character. And you can actually see this new line character if you just print out the contents of very long string. So don't use the print command, just type in very long string. Notice the backslash n specifying the new line between the two sentences of the string. We've seen how you can define variables. One last thing to note about variables, you can actually use the del keyword to undefine or delete variables. The variable very long string existed in our program. Now when you use the del keyword and try to access the very long string variable, you'll get the name error that we've seen before. This variable is no longer defined, which means it's not available for us to use. The del keyword literally removes that variable from our program's memory so that you can no longer access the value in that variable. So far, we've explored primitive data types in Python. These data types include numeric values such as floats and integers, strings, the Boolean data type, and we've also seen the none type. In this demo, we'll work with more complex data types that allow us to store collections of values. These collections can be of different types. Now, the first complex data structure that we look at is the list. A list is an ordered collection of elements. So each element has a specific index position in the list. Also, a list can contain duplicates. So you can have two elements with the exact same value in a list. A list in Python is defined using square brackets and it contains an ordered sequence of items. Here I've defined a variable called empty list, which essentially holds an empty list. You can just see the empty pair of square brackets there. Let's print out the contents of this empty list. Observe the string that I have specified to this print function. I have said empty list colon %s. The %s here is a placeholder for a string that I want to display, and that string is the string representation of the empty list. So I have the string in quotes, then a percent, and then empty list. So the string representation of the empty list will replace that %s placeholder. So you'll get empty list and an empty pair of square brackets. Here I've used string formatting. Once again, the %s is just a placeholder for a value that I want to insert into that string, and that value is just the empty list, represented by a pair of empty square brackets. Another way to specify an empty list is to use the list function with the parenthesis. What I've done here is invoke the list function, which will just initialize an empty list for me. And you can see the print output here. It's the same empty list and a pair of square brackets representing the empty list. A list is much more useful if you have elements within a list. And here is a list of string elements where each string element represents a country. This list contains 4 different elements, the 4 different countries that you see here on screen. Let's use the type function to view the data type of this countries list variable, and you can see that countries list is of type list. This is a complex data structure in Python. Once you have a list of elements, you can access the individual elements in the list by using square brackets and a list index. Countries list of 0 will give you the very first element in the list. And this is an important fact that you have to get used to. Indexing of list elements starts with 0. So the first element of the list is actually at index 0. The second element of the list is at index 1. So countries list of 1 will give you the second element of the list, which is the country France. If you look at the original countries list, United States comes first at index 0 and France comes second at index 1. You can also use negative indexing with Python lists, and if you come from Java, this is something strange. Countries list of -1 will give you the last element in the list, which is Japan. Negative indexing looks up the list in the reverse direction. Countries list of -2 will give you India. You can also use the square bracket notation to modify elements in the list. Here, I have set countries list at index 2 to be India in all uppercase. And if you now look at the entire list contents, you'll see that the country at index 2, which previously was India with I in capital and the rest of the letters in lowercase, is now India all in uppercase. Now that we know the basics of lists, we can turn to our assistant for help. Let's ask ChatGPT how we can add elements to a countries list and remove elements from a countries list. Once again, I use code generation with comments. And here you can see that ChatGPT gives us a whole number of examples. You can use the append function to add an element to the end of the list. One thing to note here is how these functions are called on the list itself. Countries list.append appends USA to the end of the countries list. The append function modifies the list on which the function is invoked. You can use the extend function to add multiple elements to the end of the list, and you can use the insert function to add an element at a specific position. You can remove elements from the list using the remove function. You can also remove the element by index using the pop function. And you can use the del statement to remove elements by index. We'll just explore a few of these functions, not all, starting with the append function. I leave it to you to explore the remaining functions on your own. I'm going to copy this bit of code over and append a number of different countries to the existing countries list. And you can see that all these countries, USA, Canada, and Singapore, have been added to the very end of the original list. Next, we'll use the extend function to add multiple elements to the end of a list. Notice I have a new list called new countries, which contains France, Germany, and Spain. And I invoke the extend function on the first countries list.extend, to append these new countries to the end of the original list. France, Germany, and Spain are at the end of the original countries list. Now, removing an element from the list is easy. You use the dot remove function. Make sure you specify the element exactly as it appears in the list. Countries list.remove India in all uppercase will get rid of the country India in the countries list. ChatGPT had also suggested the pop function that allows us to remove elements by index. Here I call countries list.pop1. This will remove the element at index 1, which happens to be France. The pop function invoked on a list also returns the element that was popped or removed from the list, which is why the removed country variable now contains the country that was removed, which happens to be France in our case. The countries list.remove function that we used before does not return the element that was removed from the list. Remove in the first code cell takes the element to be removed and gets rid of it from the list. Pop takes the index of the element to be removed and gets rid of the element at that index position. Now, let's take a look at the countries list and perform yet another remove operation. Here is the countries list as it exists right now. Just like you use the del keyword to delete a variable so that it no longer is part of your program, you can use the del keyword to get rid of elements in a list. Del countries list in square brackets 0 will delete the first element in the list. So you can see the element United States is no longer present in this list after we've gotten rid of it. A list, as you can see here, is an ordered collection. Now, you might want to add a country to a specific position in the list. ChatGPT did give us the function for this, but let's say you've forgotten this. Let's ask ChatGPT how this can be done. I have a list of countries defined in countries underscore list, and I would like to add a new country in the second position in the list. How do I do this? And ChatGPT gives you a very clear response. It tells you very clearly that when you add a country to the second position, that is actually at index 1. Remember that index positions start at 0 in a list. So the right function to use is the insert function, and you have to specify the index position 1. So let's do exactly that. Countries list dot insert at index position 1. I want Germany. And Germany will now be at the second position in the list. The second position is the index 1. Another thing to note here, remember I told you that a list is an ordered collection of elements that can contain duplicates. Observe that the element Germany appears twice. So far, we've been working with lists containing string elements, but lists can contain any kind of elements. For example, here is a list of student ages which is comprised of integer elements. This is a perfectly valid list, and all of the operations that you performed on string lists can be performed on integer lists as well. A list can also be made up of floating point values. Here is a list of student GPAs containing floating point values, and this is a legitimate list in Python as well. A list in Python can also contain elements of different data types, though such lists are rare in practice because they are hard to use. Here is a list containing all information about someone named Doris. We have a string, the name Doris, we have an integer, the age 23, Doris's GPA 3.3, whether Doris is a student or not, true, and the name of the university, Columbia University, which is again a string element. This mixed list is a perfectly valid list, and you can have lists which contain other lists as well, or you can have lists contain other complex data structures such as tuples, dictionaries, sets, and so on. All of these other data types we'll study in the videos coming up ahead. Another data structure that you can use to store an ordered collection of elements in Python is the tuple. Now, tuples work very much like lists, but the one difference between a tuple and a list is that a tuple is immutable. Once you've created a tuple, you cannot modify the tuple. Let's first initialize and display an empty tuple. Observe that I use the parenthesis to initialize an empty tuple, and I print the empty tuple out to screen. Another technique you can use to initialize an empty tuple is to use the tuple keyword followed by parenthesis. This invokes the tuple function and allows you to create an empty tuple. Let's take a look at the type of this empty tuple variable, and you can see that its type is tuple. Now, let's create a tuple with a few elements in it, and we'll see what operations are possible on a tuple. Here is a tuple of tech companies containing 5 different tech companies. Observe how a tuple is specified using parentheses and not square brackets. Just like with lists, you can use indexing to look up elements in a tuple. For example, if you want the second element in a tuple, you'll use the index position 1. Tech companies of 1 will give you Google, which is the second element in our tuple. Again, just like with lists, you can use negative indexes to access the elements of a tuple in the reverse direction, starting with the last element. Tech companies of -2 will give you the second to last element in the tuple, which happens to be Tesla. Now, if you work with tuples in exactly the same way as you do with lists, what's the difference between a tuple and a list? Let's try assigning a new value to the tuple tech companies at index position 2, and here is where you'll see a difference. Observe that this assignment statement results in an error. Tuple object does not support item assignment. The error is fairly clear, but I'm going to copy this error over and paste it into Google Bard to see what Bard has to say. Observe that when I specify my prompt here in Bard, asking Bard to debug this error, I haven't been very precise. Notice that I say, I'm trying to update an element in my list, but I get this error. Could you tell me what's wrong? I've used a tuple, but I refer to it as a list. But the error is an error that I get from the tuple. Let's see what Bard has to say. And even though I haven't been very precise, Bard looks at the error and correctly identifies that I'm working with a tuple. Bart tells me very clearly you're trying to assign a new value to an element in a tuple, but tuples are immutable, meaning that their elements cannot be changed once you've defined those elements. And Bard helpfully gives you some code showing you how you can change the elements in a tuple. And the way you'd actually do this is by converting the tuple to a list, updating the element that you want to update, and then converting the list back to a tuple. Let's take a look at this code here. On line 1, we reinitialize the tech company's tuple to Google, Apple, Amazon. Then we convert the tuple to a list using the list function. This is on line 4. Now that we have a list is mutable. We make the change on line 7 where we assign the element at index position to MSFT, the ticker symbol for Microsoft. We've seen that lists are mutable, they can be updated. So the tech companies list will be updated with this new value. Now that we have the updated list, we convert that back to a tuple. The code on line 10 uses the tuple function. We pass in the tech companies list to that tuple function to get the tech companies tuple back again. And you can print out tech companies and you can see that it contains now Google, Apple, and MSFT. Just a heads up that really you should not be writing code in this way. This shows you how you can update a tuple, but you should not be using a tuple in the first place if you plan to modify any of the elements that it contains. Now that you've seen that lists are mutable but tuples are immutable, let's ask Bard to compare lists and tuples. And I actually want Bard to perform this comparison based on a few specific details that I'm interested in. I want to take into account the syntax, the operations, the performance, and use cases of lists and tuples. The kind of prompt that I'm using here is referred to as chain of thought prompting. Chain of thought prompting basically guides your model towards a specific answer. Here, I've specified the individual steps or points that the model has to consider while comparing lists and tuples. And you can see that Bard follows my chain of reasoning and talks about the syntax difference between lists and tuples and gives me a few examples as well. It then talks about the operations that can be performed on lists and tuples. And here you can see that Bard very clearly states that lists are mutable but tuples are immutable. You can see all of the examples for operations here, and at the bottom here, it compares tuples and lists using performance and use cases. And here is an interesting detail for you to keep in mind. Tuples are generally faster than lists because tuples are immutable and do not have to support the various operations that lists do. And here at the bottom, we have the use cases for lists and tuples. Now, whenever you ask Bard to perform a comparison, it usually generates a nice little table giving you a quick overview of the various points of comparison. Now, with this done, let's ask Bard one more question. What kind of elements can I store in tuples? And you can see that tuples can hold all kinds of values. Tuples can store primitive types such as numbers, strings, booleans. It can also store more complex types such as dictionaries, sets, lists, and even functions. Tuples are extremely useful in Python if you want to store an immutable ordered collection. In this demo, we'll work with another collection data type, the set. Just like a list and a tuple, a set can hold a collection of elements, but there are important differences between lists and sets. Both lists and tuples can contain duplicate elements, however, a set cannot contain duplicates. Both lists and tuples have an inherent ordering to their elements, a set has no inherent order. Keeping these differences in mind, let's see how you can work with sets in Python. Now, the only way to initialize an empty set in Python is to use the set function. Here, the set function initializes an empty set. If you invoke the type function on this empty set variable, you'll see that the type of this variable is set. A set is one more of the complex data types that Python supports. In order to understand how sets work, I'm going to initialize a list and a set with the same elements and show you how they are different. Here is a numbers list. Observe that there are duplicates present in this list. The number 500 is present twice, as is the number 200. A list and tuples to support duplicates. So you can have two elements with the exact same value, but this is not allowed in a set. Here I initialize a number set with exactly the same elements as the list. Note that I have the number 200 specified twice and the number 500 also specified twice. Another thing to note here is I use the curly braces to define a set with elements. Now, a set with elements can be defined using curly braces, but you cannot use an empty pair of curly braces to define an empty set because an empty pair of curly braces actually defines a dictionary. Here I've defined a number set with 7 elements, of which 2 are duplicates. But when you look at the actual number set after you've initialized it, you see that it contains just 5 elements and none of the elements are dupes. And this is where a set is different from a list. A set cannot contain duplicate values and a set has no inherent order. You cannot use square brackets with index positions to look up values in a set. Now that you have a fundamental idea of how sets work, let's turn to ChatGPT and let's figure out what kind of operations you can perform on sets in Python. Now, operations on sets will not be the same operations that you can perform on lists and tuples. ChatGPT shows you the operations to create a set. You can add new elements to a set using the add function. You can remove elements from a set using the remove and discard function. Remove raises an error if the element is not found in the set, but discard does not. Now, you can perform other set operations as well, such as union, intersection, difference, and many more. And there are a whole number of other operations here. We won't explore all of these operations available. I'll leave that to you as an exercise, but we'll look at some important operations suggested by ChatGPT, starting with the ability to add elements to a set. Here I've added 2 elements, 1000 and 100. If you remember, the element 100 was already present in the set, so it's not re-added. Remember, a set contains no duplicates. The integer 1000 has been added to my set, but 100 has not because 100 already exists in my set. You can remove an element from the set by using the remove function. Make sure you specify the element accurately. Here, remove 300 gets rid of the element 300 from the numbers set. Now, if I try to remove 300 once again, remember 300 does not exist in the set, this will throw an error. The remove function on a set will raise an error if the element is not found in the set. Now, if you want to be able to remove elements if they exist without having it raise an error, you can use the discard function. So instead of remove, if you invoke the discard function, the element will be removed if it exists, but there'll be no error if the element does not exist in the set. Discard 300 does not result in an error, whereas remove 300 did. If you remember sets from your high school math, there are a number of different operations that you can perform on sets, and these operations are supported in Python as well. In order to show you how these operations work, I'm going to set up 2 sets. One that contains multiples of 5 and another that contains multiples of 10. If you remember ChatGPT's response on what operations can be performed on sets, you can see a whole bunch of set operations listed: union, intersection, difference, and symmetric difference. Let's perform each of these operations and understand how they work. You can compute the union of 2 sets using the pipe operator. Multiples of 5 union multiples of 10. The union operation combines the elements of both sets together into the final result. So this union set here contains elements from both the multiples of 5 as well as the multiples of 10. Any duplicates have been removed. You can also invoke the union function on a set to compute its union with another set. Multiples of 5 dot union multiples of 10 will compute the union of these 2 sets, and the result is stored here in this union variable. Every set operation that I'm now going to show you has a corresponding function that can be used to perform the same operation. Operations such as intersection, difference, and symmetric difference. The ampersand symbol can be used to compute the intersection between 2 sets. The intersection will give you those elements of the 2 sets that are in common. So intersection of multiples of 5 and multiples of 10 gives you 10, 20, 30, and 40. Before we perform some more operations on sets, I'm going to print out the contents of the 2 sets, multiples of 5 and multiples of 10. So they're available here on screen, making it easy for us to look at the results and see whether the results look right. You can use the minus sign to compute the difference between 2 sets. Multiples of 5 minus multiples of 10 will remove all elements from the set multiples of 5 which overlap with the set multiples of 10. The difference between these two sets gives us 5, 15, 25, and 35. These are elements that are present in multiples of 5 but are not present in multiples of 10. The elements that were in common, 10, 20, 30, and 40, have been removed from multiples of 5 to give us the difference. The difference only contains those elements that are present in the multiples of 5 set but not present in multiples of 10. Now, if you want elements that are present in either of the sets but are not present in the intersection set, you'll compute the symmetric difference. And this can be done using the caret symbol. Let's take a look at the result, and the symmetric difference will become easier to understand. The symmetric difference contains elements from the multiples of 5 set and elements from the multiples of 10 set, but it does not contain those elements that are present in common between multiples of 5 and multiples of 10. So elements 10, 20, 30, and 40 are not present in the result, but elements 5, 15, 25, and 35 from multiples of 5 are present in the result, and elements 50 and 60 from multiples of 10 are present in the result. There is one more complex data structure that's very commonly used in Python, and that is the dictionary. A dictionary stores information in the form of key value pairs. Each key is associated with some kind of value, and you can look up values using the key. There is no inherent order of the items that you store in a dictionary. Dictionaries are used to store mappings where keys and values are associated with one another in some way. Now, here is how you initialize an empty dictionary using a pair of curly braces. Remember, we use curly braces to initialize sets as well, but you cannot initialize an empty set with a pair of curly braces because a pair of curly braces represents an empty dictionary. Now, you can also use the dict function to initialize an empty dictionary. So you can simply call dict and then you use the parenthesis to actually invoke the function. This is how you set up empty dictionaries. Just like lists, tuples, and sets, a dictionary is a data type that Python knows and recognizes. It's one of the built-in data types. And if you invoke the type function on the empty dictionary, you can see it's of type dict. As I mentioned earlier, a dictionary is made of key value pairs. Let's say you wanted to store the math scores for various students in your class. You'd have the name of the student and the math score for each student associated with the name. And the dictionary is a perfect structure to store such bits of information. Observe that I open the curly braces of the dictionary on line 1 and I close it on line 6. So I've used multiple lines to specify this dictionary, nicely formatted, so it's easy for you to see the key value pairs. James, Nora, Janet, and Richard are the keys, the student names. Observe that we have a colon following each key and then we specify the value. 89 is how much James scored in math, 55 for Nora, 96 for Janet, and 43 for Richard. Each key value pair is separated from the next pair using a comma. You can see the comma at the end of each of the lines 2, 3, and 4. Now, let's take a look at the structure of this dictionary. We'll print out the contents of student math scores, and you can see that the dictionary has been set up. Since we are learning Python using prompt engineering, let's turn to Bing Chat this time in order to see what operations you can perform on a dictionary. I'm going to start off on a new topic so that Bing doesn't have any previous context of what we've discussed. Here's my question to Bing. What kind of operations can you perform on Python dictionaries? This is a great way to get an idea of how the different data structures work. And Bing gives me a bunch of responses. It shows me how I can access values, update values, delete key value pairs, check if a key exists, and clear dictionaries. We look at some of these operations. We won't go through all of these. You have the fundamentals at your fingertips. I leave it to you to explore many operations on your own. Here is how you look up the value associated with a key. So if you want to know how much Nora scored in math, you use the square brackets with the dictionary, and within square brackets, you specify the key that you're interested in. Here I'm looking up the scores for Nora, and you can see that Nora scored just 55 in math. Now you might say, oh, I want to know how much John scored, and you look up the value associated with John using the same square brackets, but observe that we haven't actually got a John in our class. If you try to access a dictionary key that does not exist, you'll get a key error. And the key error basically tells you that this key does not exist in the dictionary. Let's now see how you can update a value associated with a key in a dictionary. Here is our dictionary. I've just printed it out to screen. so that it's readily available to us. I want to increase Nora's math score to 65. All I have to do is access the dictionary, use square brackets to specify the key that I want to update, and then assign the new value to the key. You can see that Nora now has a math score of 65 as opposed to 55 earlier. Essentially, when you look up the value associated with a key, you can treat it like any other variable in Python. Let's say I want to increase Richard's math score by 10%. Here is how I can use the in place multiplication operator to do this. Observe the left hand side of the in place multiplication operator. I use the value associated with the dictionary key just like any other variable. And you can see that Richard's math score has been incremented by 10%. And we get that little fractional part when we work with floating point numbers. Let's say you were to add a new key to the dictionary. Well, you do it the same way like updating an existing key. Julian is a new student in my class, so I access Julian as the key using square brackets and assign his math score to 72. And you can see that Julian has been added as a key along with the corresponding math score as a value to my current dictionary. Let's look back at Bing's response to see what other operations are supported by Python dictionaries. Notice that you can iterate over keys and values using a for loop. Now, we haven't done for loops yet, but observe that you can access the values of a dictionary by calling dictionary.values. And point number 3, you can also delete a key value pair using the del keyword. Those are definitely some operations that are worth exploring. Let's see how you can access all of the keys in a dictionary. You simply invoke the dot keys function on the dictionary object. This will allow you to access all of the keys in the dictionary as a list. In a similar way, you can access all of the values in a dictionary by simply calling the dot values function on your dictionary's object. And here are all of the values associated with each of the keys. If Richard is no longer part of my class and I want to delete the key value pair associated with Richard, I use the del keyword and I specify Richard as the key. This will get rid of the entire mapping for Richard. The remaining key value pairs remain untouched. The values that you store in a dictionary can have any data type. They can be strings, booleans, floating point values. They can also be lists, tuples, sets, or other dictionaries. Here is a dictionary where values are of different types. We have an integer value 89, 3.4 is a float, and you can see that the Janet key has a list value and Richard has a string value. Here is a mixed dictionary, and this is totally legitimate and valid in Python. The keys in a dictionary can also be of different data types, but there are some constraints here as we shall see shortly. Here is a dictionary where all of the keys are integer values 11, 22, 33, and 44. The values are strings. Here you can imagine that the keys are the IDs of each of the students in your class. Now, it's possible that in your school, students are identified by a pair of values. They have an identifier that is an integer, and they have a letter that is of type string. And you try to set up your dictionary in this manner student info, where the keys are all lists, where the lists have a pair of values. You're quite happy with this code that you have, but you encounter an error that says unhashable type list. Now you're not sure what this means, so let's turn to Bing Chat for help. I've copied the error over and I tell Bing Chat, here is a dictionary that I tried to create with this code, but I get this error, unhashable type list. Let's see what Bing Chat has to say. I ask Bing Chat, what does this mean? And for these simpler errors, generative AI is very useful. This error is raised when you try to use a mutable object like a list as a key in a dictionary. Lists are mutable, which means they can be changed after they are created, and mutable types cannot be used as dictionary keys. Dictionary keys have to be of an immutable type. Not only do you get an explanation, you also get an example of how you can actually change your code to use tuples instead of lists. Remember that tuples are immutable. The keys of the dictionary that Bing has suggested contain tuples to hold pairs rather than lists. So let's head back to our Jupyter notebook and let's use tuples to represent the keys of the dictionaries. And you can see that this dictionary has been successfully created. Let me now show you how dictionaries can hold complex objects as values as well. I'm going to ask Bing to generate some code for me. I've asked it to create a dictionary where the keys are student names and the values are student scores in math, English, and science. You can see that multiple values are associated with the same key, which means the value for each key is a complex data type. The keys are all names of students: Nora, Julian, Desmond, and Clarice. And the value associated with each key is a dictionary, and the keys in that dictionary are the names of the subjects: math, English, science. And Bing has also given me code for how I can look up the individual subject scores for each student. Let's copy this code over and execute it and play around with it in our Jupyter notebook. The values here are a complex data type, the dictionary, and the dictionary allows us to represent the math, English, and science scores for each student. What we have here is a dictionary inside another dictionary. This is a nested dictionary. Now, if I want to access all of the scores for Clarice, I simply access the key Clarice, and this will give me the dictionary of scores associated with her name. Let's say I wanted to access or update Clarice's science score. I'll now need two square brackets. The first square bracket looks up the scores for Clarice. So you can see the key I've specified as Clarice. The second square bracket looks up the science score, and I update Clarice's science score to 76. Now, if you look at the student info dictionary, you can see that Clarice's science score has been updated from 95, that's what it was earlier, to 76. That's what it's now.